All right, hello guys. Welcome to your Unit 5 explanation video. Now on this video, I am not going to do 5A and 5B separately because Chapter 5 is really easy. And since we're doing everything from home and there's no way for me to control what you're looking at while you're doing this stuff, this is going to be an extremely easy chapter. I'm going to do A and B together right now today. And I'll kind of explain how everything works. With Chapter 5, there's two worksheets. There's an A and the B, and basically the first worksheet A is sine, cosine, and tangent, and the second one is all the other ones, so secant, cotangent, and cosecant. So we're going to do it all together because it just lends itself really well to this. Please realize that if we were doing this in class, this would be a lot harder because on the test, what I had kids do is they didn't get to use any notes. They had to recreate the whole chart that you look everything up off of. And then they also had to recreate all the graphs. So you're kind of getting out of a lot not having to do all that. But, to be fair, it's mostly memorization. So, not the hardest thing in the world. But it's what it is. So go ahead and find your worksheets A and B. And I think before them there's this worksheet right here. And basically this is kind of some notes to fill out. So I'm going to tell you what to write in each of these, okay? There's also this table. This table will make a lot more sense as we go through this. But basically we're going to fill out all these values so that we can look them up off the table. Now, when you do this test for this chapter, it's not going to be a thing where I send you a worksheet, you do it on a piece of paper and send me a picture of it. I'm going to actually try and come up with like a kind of a Google spreadsheet or a Google survey kind of thing, and you'll just do your answers on there. And basically it's just going to be looking up values off a chart. So if you can read a chart, understand what it means, understand a bit of vocab, this test should be really easy compared to everything else we've done. Okay, so first of all, on the top of worksheet A, we have these three blank graphs, and we need to fill those in. First of all, before we even get into this, what we have to realize is what we're talking about. So in this chapter, we're talking about inverses. This is a normal sine curve. It starts at 1, goes down, and comes back up and does a full period within 2 pi. Well, if we turn this and kind of flip it over the y equals x line, we get something that looks like this. So it goes up and down. Well, this is the inverse function, and we really can't call it a function because if we did the vertical line test, it would hit all sorts of points. It would hit infinite points depending on how high you went up and down. So what we do is instead of it going all the way up and all the way down, kind of zigzagging like a snake, we're going to restrict the domain. So we're going to just say that sine goes from one point to the other point so that it passes the vertical line test. So it'll just be a snippet of this curve. So I think you'll see what I mean. So first of all, on your note sheet, go ahead and copy all these down. And this is kind of, it's for notes really. I rarely look at this. What I like to look at is the graphs. So copy this down to have it, but like I said, if you don't use it, it's not going to be the end of the world, okay? And this is telling us exactly how we're all kind of agreeing to restrict the domain, because you could do it a lot of different ways. So this is how it's done for this chapter, okay? Now, this is a normal sine, cosine, and tangent curve. They don't have the x-axis like kind of darkened on these, but these are what they look like. We've been dealing with these, so hopefully this isn't too unusual for you. So let's start with the graphs. So your paper has blank graphs like this, and the domain and range is on there. So this is what you're going to copy down onto there. So cosine is starting at 1, and it's kind of going up, and it ends up at -1 on the other side. So the domain on that, or the x values that we are plugging in for that, are going from -1 to +1. And the range for that one is it's starting at 0 and going up to pi. Okay? Remember, y is dealing with range and x is dealing with domain. Okay, sine actually goes negative on the y scale. So this one goes from -1 to +1 for a domain, And range starts at negative pi divided by 2. It goes up to pi divided by 2. And then tangent, we're just basically taking one of those kind of S curves, and we're just using that. So we're going to have an asymptote at positive pi over 2 and negative pi over 2, just like we did going up and down on regular tangent curve. And the domain on this one, it goes negative infinity. It goes back as far as you want, and it goes forward as far as you want. So this one doesn't have any restrictions on the domain. Be very, very mindful when you're talking about infinity. There is no equal to on those, whereas all the other domains have like greater than or equal to or less than or equal to. So though, if we go to infinity, it doesn't have that. So this is what we're going to be looking at in terms of all of our answers. Okay, so this is where they're restricted. Okay. Now, like I said, on the test, I made the kids last year recreate these, so they had to memorize these and then redraw them, and not just these 3, but all 6. So just realize you're getting out of that as well. Okay. So now, first one we're going to talk about is sign for this one. Now, one thing that they do on here, and it's not super straightforward, is they have the sign with the little -1 exponent. That means inverse sine. So basically, that's what we're talking about. Now, the other way to write that is arc sine. So arc sine and sine with a little -1 next to it, those are saying the exact same thing. So please don't be confused by that nomenclature. Okay. So for the first one, it's saying, what is the inverse sine of a positive half? So we go to where our thing is, our graph, and we're going to positive half. Well, it's not really indicated on this graph. We can't really tell because it goes to 1 and it goes to -1. So it's somewhere in between 0 and 1, right? So we have to go to our chart, okay? Now, sine, we said, was restricted from negative pi divided by 2 to pi divided by 2. So the only part of the unit circle that we're talking about is the right side. Everything on the left side is excluded because we have we restricted the range on this one. So we're looking for where sine is a positive half. All right, so we're looking for where sine is a positive half. Well, remember it's written as cosine comma sine. So we're looking for the second number in those coordinates is positive 1/2. Well, the two places that the one place I see it happening, it doesn't happen twice. The one place I see that happening is at square root of 3 over 2, comma 1/2, which is at pi divided by 6, or 30 degrees. Now, you can write it as radians, or you can write it as degrees. Doesn't really matter. But our single answer for that is going to be pi divided by 6, or 30 degrees for the first one. Okay. Second one says, what is the arc sine of square root of 2 over 2? And that is positive. So once again, we're looking at all the coordinates. We're looking for a positive square root of 2 over 2. Once again, this is talking about sine, so it's the second number. Well, that happens at 45 degrees, or pi divided by 4, because it's square root of 2 over 2, comma, square root of 2 over 2. And that second number, that second square root of 2 over 2 is what we're looking for. So the answer here is just 45 degrees, or pi over 4. Okay? All right. So now, one thing I did want to mention is we're going to fill out a chart just like this, and it's going to make looking these things up a lot faster. So if you want to copy this down now, cool. If you want to wait till I show you exactly how to do it at the end, feel free. Okay? Let's talk about number 3 and 4. So number 3 says we're talking about the arc cosine, or the inverse cosine of -1/2. And the other one is the cosine with the little -1. Once again, that's still inverse cosine of -1. So we're going to find -1/2 and -1 and write down our two answers for these. So we're looking at this. Now, cosine is restricted. It's going to be from 0 to pi. So 0 to pi on our unit circle is just the top half of the circle. We don't care anything about the bottom because we've restricted this. Okay? So we're looking for, what was it again? -1/2 and -1. Well, -1/2 doesn't happen in the first quadrant. We're looking at the first number in the coordinates, remember? And it does happen at 2 pi divided by 3, or 120 degrees. If you look at that spot, the coordinates there are -1/2, comma, square root of 3 over 2. The -1/2 is what we're interested in. So what we would write for an answer on that problem is either 2 pi over 3 or the 120 degrees, either one. Now, number 4 said -1. So once again, we're looking for a -1, and we don't find it until we get all the way over to pi. So at pi, we have -1 comma 0. The -1 is what we're interested in. It's a -1. So for this answer, we're going to write either pi or 180 degrees. So basically, we're just looking these up backwards. Okay? All right, last ones. We got tangent, or inverse tangent of 1, and the arc tangents of -1/2. Remember, tangent with a little -1 and arc tangent are saying the exact same thing. They're both inverse of tangent. Now, tangent is difficult because we can't just look for our coordinates on the unit circle. Remember that tangent is sine divided by cosine. So what we're looking for is our two coordinates. If we divide them, that's what we're going to get as a result. So for this one, we are restricting the range from -pi/2 to +pi/2, so it looks just like a sine. We're only interested in the right side of the unit circle. And so for the first one, we're looking for a +1. Well, looking at the coordinates, you're never going to find a +1 because it just won't exist. But what we do know is that sine divided by cosine is a tangent. So we're looking for the two coordinates. When you divide them, you get a +1. So two things that are exactly the same, either both positive or both negative. Well, the only spot that happens is at 45 degrees or pi divided by 4. At that point, you have square root of 2 over 2 and square root of 2 over 2. If you divide those, they're the same thing on top and bottom, and you're going to get a +1. So the answer for the, I think it was arc tangent, or maybe tangent inverse, whatever. The inverse tangent of +1 is going to be either 45 degrees or pi divided by 4. And that's because those two divide to make a +1. Now the second one, we're looking for a -1/2. This one's quite a bit more difficult because we need to get that negative, and it has to work out to be a half. So this one's going to be proved to be a bit more difficult. So if we look at all of these, none of them jump out to be a -1/2. So instead of trying to rack your brain on which coordinate here divides to be a perfect 1/2, what I'm going to do is I'm going to jump to my table, and this isn't cheating. This is how you do it. And we're going to look at on this sheet for -1/2. Well, that never shows up on the chart for tangents. Okay, so for this one, I'm looking in the top box and the bottom box. I have square roots of 3. I have 1s, positive and negative. So none of that looks like -1/2. So there is no way to do this without using like a calculator on this one. So what you would want to do is you can either leave it as the inverse tangent of -1/2, or you can use a calculator. So now when I use a calculator, and if you don't have your graphing calculator at home, you can find this on most computer calculators. I think even, well, almost all phones have a scientific calculator for free. But I'm going to do second inverse tangents of -1/2, and I plug that into my calculator because I brought my TI-84 Plus home. And what you're going to get, my calculator is in degrees, so I got -26.5, I would call it 7.57 degrees. If you want it to be in radians, you switch calculator radians, and you'll get some decimal will be real small. And I don't know, I would do it in degrees. Okay, but like I said, on the exam we're going to have for this chapter, everything's going to be multiple choice, so your answer will be there no matter what. So this one, we can't use a chart, we can't use a unit circle. Well, we can't use the chart that we have because it's not doesn't have enough numbers, but using a calculator for this one is totally fine. Okay, so if it's not on the unit circle, use a calculator. Okay, so that is all of worksheet A. On worksheet A, they give you 6 problems on sine, and basically you're just going to look at a chart and figure them out. Those are pretty straightforward. Cosine, same thing. They give you 6. You just look them up. It says without using a table or a calculator. you have to use a calculator or a table, or you're at home. How would I ever know? And then the last one is all tangents, so you're going to do those. Now, if you have any mistakes, or not mistakes, if you have any questions on any of those and you want me to work one out for you, I will, but they're very, very straightforward. Like I said, you probably want to use this table, and this table, I color-coded all the regions on here. Remember, with sine, we restricted the range on it, so we don't have any of those things outside the purple boxes. Cosine, we did the same thing. Tangent, we did the same thing. Cotangent, secant, and cosecant, those are going to be restricted as well. So for this chart, this is going to be incredibly useful. Like when you take your test, you're basically going to be looking them up off of this. Okay, so it's going to be very, very straightforward test. Everyone should get 100% or close to. I understand people make mistakes when they look stuff up, but it should be straightforward. Okay, so that is sine, cosine, and tangent. Now, cosecant, cotangent, and secant, here are the notes for it. I don't know, these ones get a little goofy because we have some division in it. So we, like, for some of the ranges, they say y cannot equal 0, or y cannot equal pi divided by 2, and that's just because you run into the problem of dividing by 0, and then you get infinite stuff and errors on your calculator and stuff like that. So it turns into a big mess. Now, the one that is really weird is cotangents. If you look at cotangent, we got 3 scenarios. If it says, for the first one, it says, use this if x is bigger than 0. For the middle one, it says, use this when x is less than 0. And the bottom one says, well, if you have 0, use this one. And your answer is just pi divided by 2. So this one is really, really goofy, but we'll work through it, okay? Once again, we have 3 graphs. So this is a normal cosecant, secant, and cotangent. So to plot the inverse versions of these, where we restrict the domain and range, we get these. Now, go ahead and copy these down because I think that's useful. But looking at the domain and range for the first one, which is secant inverse, this one part of it is going to go to positive, or start at positive 1 and only go up. The other one starts at -1 and only goes down. So we have kind of this gap in the middle. Another weird thing is we have this asymptote in the middle. So they both get infinitely close to that pi divided by 2, but they never ever touch it. And that's why our range, it says y cannot equal pi divided by 2, because that's an asymptote. They never ever touch that line. With cosecant, this one's interesting as well. We have a similar thing. We have a gap in the middle where it starts at 1 and goes to infinity, starts at -1, goes to negative infinity for our domain. With range, the asymptote here is just this x-axis, so y can never ever equal that 0. It'll get infinitely close, but it will never ever touch. Now, cotangent is a lot like tangent, except now the S-curve kind of goes the other way. The range, or the domain on this, it goes back forever, it goes forward forever, so it's going to go from negative infinity to positive infinity for your x's. And the range, it's going to stay in between 0 and pi, but remember, this one will never ever touch that pi and will never ever touch that 0, so there's no equality there. So those are our new 3, or the next 3, I should say. So you're going to use those to answer a bunch of questions. And once again, we're just going to fill in a chart, look up our values on the chart, and this is going to be a piece of cake. All right. So for the first one, we have secant, inverse secant of -2. And then the second one is arc cosecant. So they mixed it up. They didn't do 2 of the same, which is annoying, but that's what they did for us. So let's look up the first one. So for the inverse secant of -2, I'm going to look at my chart. In the red area right here, we just look for a -2, and that -2 matches up real nice with 120 degrees and 2 pi over 3, because there's a -2 for secants. Okay, so you're looking up backwards. All right. Next one, we have the arc cosecant of pi over 2. So we go to our chart. Come on. Arc cosecant of, was it positive pi over 2 or negative? Positive pi over 2. And that matches up real nice in the yellow region, the top yellow region, with 45 degrees or pi divided by 4. Okay, so that's number 1 and 2. Number 3 and 4. Number 3 says, oh god, that has a radical in the bottom. That's not kosher, but it's what they gave us. So let's see what this is. So it says the arc cotangent of -1/3 or 1 over square root of 3. So what we have is we look in our cotangent region right here, and we don't see that answer. Now, the problem is they fixed that radical in the bottom when they made this chart. Our question is not asking us in the correct form, so we'll have to get rid of that radical in the bottom. So we multiply the bottom of this radical by the square root of 3 and the top of it by the square root of 3. On the bottom, you would be left with a 3, because square root of 3 times square root of 3 is 3. On the top, you would have 1 times the square root of 3, which is just the square root of 3. So if we put this in the proper form, it's going to be the square root of 3 on top, a regular 3 on the bottom, and everything is going to be negative. So we're going to say negative square root of 3 over 3, and that is on our chart. That is at 120 degrees, or 2 pi over 3. Okay, so that's how you do that. I guess that's a little tricky, but not too bad. Now, this one is really, really interesting. It's saying, what is the inverse sine of cosine of pi over 6? So just like your Algebra 1 problems where it was like, please excuse my dear Aunt Sally, we start with parentheses, and then we kind of work our way out. We're going to start with the inside of the parentheses here. So we're going to figure out what cosine of pi over 6 is first, and then we're going to take whatever that answer is, and we're going to find the inverse sine of this. So we go to our chart for this, and we're looking for cosine of pi over 6. Well, on the chart, cosine of pi over 6, and now we're looking up this in the normal direction. So we match up cosine with pi over 6 and see where those two cross, and it's at the answer to this is square root of 3 over 2. So square root of 3 over 2 is now what we're going to do the inverse sine of. So we take that answer, square root of 3 over 2, and that's what we're looking for now in the sine column. In the sine column, the positive square root of 3 over 2 shows up at 60 degrees, or pi over 3. So that's what we're going to put for our answer on that. Okay? So pretty tricky problem. Okay? Okay, so that is it for example problems on Worksheet B. If you look at the rest of Worksheet B, it's pretty similar. We have just a bunch of problems based off of these. So you're going to work through these. If you get any of those two-part ones where you have to look up one answer and then plug it into the other, just work with inside the parentheses first, get an answer, and then do the inverse trig function on the outside. Now, one thing I want to talk about real quick is Worksheet C is basically just a mix. So Worksheet A was sine, cosine, tangents. Worksheet B was secant, cosecant, and cotangent. So Worksheet C is going to be just a mix of all those. So if you go to Worksheet C, the first 6 problems are just cosine, sine, and tangents. Numbers 7 through 12 are the other 3, so cotangent, secant, and cosecant. So you'll work through these, and that's basically it for the entire chapter. Now, they didn't put a lot of parentheses on Worksheet C, so I apologize for that. There should be more parentheses, especially on 13 through 18. They should have parentheses around a lot of that, but they did not do that. So there's that. Now, at the end of Worksheet C, it says, draw the graphs, find the domains, and ranges for all 6 trig functions. Like I said, this is something the kids last year had to do, and they had to memorize it. You guys will not have to do that because you can just copy it. But one thing I would highly suggest you do is this chart that I have that I put in there for you, I would suggest you fill that out. Now, there is that kind of gray line in there, and that gray line kind of goes with 210 degrees, 225 degrees, and 240 degrees. As you can see, none of the trig functions use that area. So instead of just writing those out and putting them in there and just having them all blank for this, I just got rid of them. So it jumps from pi up to negative pi over 2, which is the same thing as 3 pi over 2. So it also has the negatives in there, which is really, really slick because it makes it easier to look them up. Okay. So anyways, fill this out. Work on those worksheets. Like I said, it's just 2 worksheets for Unit 5, and send those to me when you're done. Whenever they're done, just send them to me. I will have the test up on Schoology. I'll put a link up on Schoology, and I will do that at the beginning of next week. Today is the 22nd of April. So that will be next Monday. I'll put up that test. And like I said, it's going to be a multiple choice test. I think you'll only be able to take it once, so don't goof up or anything like that. And it should be pretty straightforward. It's just going to be 10 multiple choice things. Can you look them up and not goof it up, basically? Okay? Like I said, if you have any questions, feel free to email me, and I will get to those as quickly as possible. I check my email every day. I've been grading a lot of Unit 4 tests and Unit 4 homeworks lately, but there's a lot of people who still need to turn that in. Also, a lot of people missed Unit 6 test and Unit 6 homework before break. There was one class that didn't get to take it. If that's you, you need to go in and take that. And then send it to me when you're done. Unit 6 is pretty straightforward. What else? Oh, this is the last chapter before we take the quote-unquote final. The final, like I said, it's going to be cumulative, but I'm going to make it easy. I'm going to probably try and do something like the test we're taking for Unit 5, like kind of a multiple choice test. It'll be more than 10 questions, though. It'll be probably closer to 25-ish. But I'm going to try and make a multiple choice test for that because I don't want to have to worry about people cheating and crap like that. I did get a question, and I explained this in an email, but I think there's still a little bit of confusion. If you are taking this class for college credit, your grade is going to go up, it's going to go down, and that's really what your grade is for CCA. Everybody, whether you're taking the class for college credit or not, if you're worried about Overland credit, the only grade that you really need to think about is what your quarter 3 grade was. So what was your grade at before we left for break? If your grade, let's say for an example, you were at an 80%. Your grade in Schoology is going to go up and down depending on assignments. And at the end, let's say you take the final, I put everything in, and your grade is at a 76. You will not get the 76, even though that's what it says in Schoology. I will go back and I will adjust your grade so that it matches that 80 that you had at the end of quarter 3. I know some teachers are not doing it that way, and I apologize that all the teachers aren't doing it the same way, but I want people's grades to go up and go down just because a lot of you are taking it for college credit, and I have to reflect that in the grade book. They couldn't create a separate grade book for me for the college class. So just realize that, hey, if I entered quarter 3 with this grade, it will not go below that for Overland's sake. If you're taking a class for college credit, it can absolutely go down. So keep doing the work, keep doing it as well as you can. And, if you're worried about your grade or anything, just email me and I'll sort you out. If you want to drop this class, they've extended that drop date to beyond the last day of class. So you can basically see what your final grade is before you decide whether or not to drop the class, which is silly in my opinion, but I've never heard of them doing that before. But the nice thing about that is if you're unsure if you want to take a class for college credit, wait and see how you do on the final. If you do well enough to get a C or better, then don't drop it. If you get lower than C, then do drop it. It's that simple. Okay? Like I said, any questions at all, email me. I'm here for you. I check my email every day. And please be safe, wash your hands, and all that. All right? Talk to you later.